Oh, nice. Okay. So let's just gonna so everyone can see my screen, right? So good.
Yep.
Okay, cool.
It's
So
all
all right. So today, so welcome to another lesson. So today, I'm gonna be talking about object-oriented JavaScript. So yeah, let's get started. So these are our values and principles. Yeah, just gonna skip over that, and then a little bit more about the agenda for today. So I was really contemplating on how I was gonna do this whole presentation. So what I went with, because there's the way that when we refer to object-oriented JavaScript, it means, well, certain people are going to tell you different things, and uh, because JavaScript, depending on who you talk to, if somebody asks you if you ask somebody whether JavaScript is object-oriented or not, I think it's very split. Some people are going to say yes, some people are going to say no, some people are going to say, yeah, JavaScript has object-oriented features, but it's not object-oriented. Some people will say no, it's object-oriented. So there's a whole, there's a whole bunch of discussion about the actual quote-unquote, object-orientedness of JavaScript. So what I decided to do was I just decided to kind of focus on the more specific JavaScript stuff, and less about comparing JavaScript to traditional object-oriented languages like Java, C Sharp, C++, like those sort of languages. So what we're going to do is essentially just go over some basic stuff, and then very quickly we're going to pick up the pace from a review to things that you might not have seen that are particular to JavaScript, and most likely you have not come up, depending on how experienced you are. You might have not seen or has ever come up in your, I guess, career so far. And so these are things like property descriptors and immutability, like things like object.freeze and CO and those type of things. And we're going to get into that. And then we're going to talk about the this keyword and go over some examples and clear up some, I guess, confusions, because I know it's a very difficult thing to understand. And so yeah, and then we're going to talk about probably the most important thing, which is the prototype system. So the prototype system being pretty much the thing that really is debatable whether or not JavaScript is object-oriented or not. And it's something that, for me, it took me actually quite a while to really understand this. And perhaps, you guys already understand it, or perhaps you're somebody like me who took a really long time after many years of writing JavaScript to even understand what the documentation was even about, right? Like a good example of this is, when you go to like the array section of MDN, you'll see something like array.prototype.reduce, right? Like the first time I saw that, I remember I'm like, I'm just gonna shrug over it. And because I already use reduce and map and for each and all these splice and slice, I already use all this. I don't need to know what this prototype thing is, or I don't really care. I'm just using it. So we're gonna dive a little bit deeper and then actually learn what is actually going on with this prototype system. And oh yeah, the infamous prototypal or prototypical inheritance, right? The thing that confuses a lot of people, especially people that come from a traditional background who don't really, like me, I was very, very confused in the very beginning until I dove a little deeper and I realized, okay, so I've been understanding this the wrong way. But yeah, anyway, so, oh yeah, and then we're going to come back to like the more traditional OOP stuff, which is actually using JavaScript, which is actually the stuff that we see with classes and all that stuff in JavaScript. It's really just some syntactic sugar. I'm just gonna, just gonna go over how it works briefly. It's just basically a comparison of the ES6 stuff to how you would do it in ES5. And I'm not going to dig really super deep under the hood about how specifically classes are is the syntactic sugar, and how how it is syntactic sugar, because I was going to use a different language, but then I realized, okay, let me just use JavaScript, because we already have classes, we already have static properties and methods and all that type of stuff. Why don't I just demo it with JavaScript instead, right? So first thing, most of you guys should know Michelle, my supporting instructor, and then me, I'm a developer at Kudo. I'm Yi-Chen, I'm a developer at Kudo, and I'm pretty sure Michelle's in every single one of these, right? So there's no need to really introduce her. So I'm gonna have a lot of code examples, and not really gonna have a lot of slides. I'm just gonna go through a bunch of stuff in the code. So here, let's. Do I need to make this even bigger? Maybe this is good enough. Size. Right. So everybody can see, right? So, okay. So the first, I'm just gonna press this. Cool. Yeah. Okay. So the first easy stuff. Let's just do some review, some basic JavaScript objects. How how objects are created, what objects are, and what are some properties. What are some of the things that we can do in JavaScript? So the first thing is, what are some ways to create objects? So objects, you can use object literal, right? You could do something like this, which gives you an object literal. You could put in some properties, right? Some keys, and then you can put some values. And then there's this thing called computer properties. I don't know if you guys have ever tried dynamically putting a property like as a variable, as a key. This is, I think, new in ES6, or I can't recall, but yeah, you can do something like this. And then if you console log this particular object out, it should be pretty obvious, right? And let me just go to, I already have it up. Let me just run this to make sure everything is working fine. Okay, cool. So for this, yeah, it should be an object with what's prop 2? Prop 2 is some prop, and then what is this? Prop 1. So this is going to be 1, 2, 3, 4, 5, 6, right? Because this gets coerced into a string, right? When you're concatenating two strings, and then you'll get the value of this, right? So that's a demo of computer properties, right? We can enumerate through properties, okay? So if we do this, right, by default, we're going to be able to get the keys of the property of the object, right? So easy stuff. Everybody knows all this stuff already, right?
Hey, Yi-Chen, I know it doesn't matter, but why does when you log out that object, why are the properties in that order instead of in the order they're declared?
Oh, that's a good question. Okay. Yeah, that's a good question. I'm just trying to recall something. Hang on. So I believe, actually, you're right. I think this should be after. Because so one of the things that I actually remember doing a lot is I wanted to get like the order of the properties. And so like you write like a for loop and then you try to get the ordering right. I remember I wrote like a helper function with that, but in this case, I'm not sure why this is first. It could be because this is like a string. But yeah, that's actually interesting. I didn't really think too much about this. So maybe like if I do this, I don't know what's going to happen here. Maybe we could just see the behavior of this right now. Yeah, it could be because of this. Like if I do prop 4, I think this is going to become first. So, oh, there, value. Prop for value. So, what are we looking at? We're looking at if these strings as keys are gonna go first, right? So this is it's gonna be prop 4, and then it's gonna be this thing, and then it's gonna be 2 and 3, right? So based off of what I'm seeing, prop 4. Wait. I see. So is it because if I do this and I want to make it dynamic? Try this. Yeah, I don't know, man. I don't know. I don't know about that, the ordering. Oh, okay. Well, it seems like my support instructor has given a nice link. Yeah, go ahead.
In general, it's not recommended to ever rely on the order of properties in objects, but there is a specific, like there are rules that govern it, and I don't know them off the top of my head, but they do exist. I can try and find a link for you all as the lesson moves on.
Yeah.
Thank you.
Pretty useful. Yeah.
Sorry, I didn't mean to derail things there. Thank you.
Yeah, thanks, Michelle. I learned something new today. Yeah, because the thing is, I remember like when I was doing some, I don't know, man. I wrote a helper before. I remember Googling this a couple times a long time ago, and I wanted like the order. So like I would have a hash map, like an object with like the keys, like 1, 2, 3, 4, 5, and then I wanted to like order it. I want to do a sort on the key so that the object is, in that order. And yeah, I never knew about like the specific details on how the things are ordered, ascending or descending. Anyway, so yeah, go ahead, Michelle.
I was just going to say the ordering is pretty new. Property order has only been predictable since ES 2015.
Okay, so yeah, so it's about like 5 years. So ES6 plus. Okay. Well, anyway, we can all look at that afterwards. So yeah, where were we at? Right. So going back to how some other basic object syntax. If you guys didn't know, well, I didn't know a long time ago. There's this thing called the global object, and it's a function that you can actually use to so you know how when you go to MDN docs, you'll see like object.keys, right? And then you'll see like object.prototype.toString. Okay, so this is kind of where the mother of all objects, okay, is instantiated automatically in the language. So you can do something like this, and you can I don't know if anybody actually does this still, but you could do something like this and create an object, and then you would just get the same exact object, right, as expected. And then of course you can also use built-in objects like number, or in this case string. So this one it's going to be, yeah, so this one it's a built-in, so instead of doing the string literal, you can create an object wrapper. Okay, so that's like a box wrapper that boxes the whatever it is, your parameter right here. It'll act exactly like a string, except it will be an object rather than the type of will be an object rather than a type of string, right? So just to prove that it's actually of a type, the capital string, it's right. Hold on, let me just right. This is true, but what's funny is if you guys didn't know, string doesn't inherit the object. So if you do something like this, right, it's gonna be false, right? So I don't know if you guys do that, but very interesting. Very interesting bit of detail.
Question for you: if you do the code from line 37 in this instance of string, are you still able to run string methods on it then?
Yes, you should. Yes, yeah. So like if I just do, all right, let's check it out right now. So if I do this, my string. Let's do yeah.
Uppercase or
Let's do this. Let's do 2. Okay, let's see. There we go.
okay.
Yeah.
So string must inherit all the methods from the prototype object then, right?
Yeah, so we'll get to that. So everything that you see here, like this, everything here, yeah, you get to be able to use it, right? And then yeah, if you're wondering what, like I said it very quickly, but if you do this, it's going to be object rather than string. So it's going to be this because we used this thing. We used this thing here. Right. Okay. Anyway, so yeah, so let's move on to some other stuff. So let's see. Oh, right. So this is probably the least. These things are not as common, but this is probably the most common. Not most common. Maybe second most common, which is you have a function. So you have a function. And then you create an object or like an object from that function, and then you can do stuff with it. So in this case, I'm not sure why I put this example. I'm not sure why I wrote this example, but you can do something like this, right? So this is literally the same as me creating an object literal. So this is just an empty object, right? But it has the type animal, this cat. And I'm just adding a property to it, right? I can, add some more properties, right? Prop 1 or name. Let's give it a name, right? Super cat, right? And then we'll be able to see what happens, right? So just like any program, we'll run it. We're expecting meow and then super cat. Okay, cat 1. Okay, right. Okay, so this is all kid stuff. I'm pretty sure everybody here knows all this stuff pretty well. We use this, in the Telus, what do you call it? In Telus, the repositories, the starter kits with React. Well, we don't use the older class-based components, we don't use those a lot anymore, but for the hooks, or not the hooks, but the functional components, that's essentially what you're doing, right? You're using functions. And then, yeah, so here, let's look at the harder stuff, which is things that you might not have encountered. So the first thing about So the thing that I want to introduce is property descriptors. So property descriptors are essentially, so whenever we have a property, so for example, name or a function or anything, right? A property that belongs to an object, okay? That property has there's three main properties to the property descriptor, to that property. So the first one is the first property, okay, of that specific property to the object is called writable. The second is configurable, and then enumerable. So let's go through an example real quick. Okay, so here we have. So I'm going to do not in strict mode, but I'm going to go and use this thing called object.define property. So it takes an object, which is my empty object right here, all right? And I want to add a property called, I guess, my value right here. All right? It could have been anything. So this is just basically me doing object3.myValue, right? Except I'm going to define some more properties on that property, okay? So I'm going to say that the value, right? The value here is my value, right? This is the exact same thing as doing this. So the part that's difficult now is we have to understand what all this means. So writable essentially is when if you have a true, so by default, I believe everything is true. So when I do something like this, everything here is true. Readable, enumerable, configurable, they're all true. So as soon as you go, and let's see, I'll put this to be true, just so we could go down one by one. As soon as this is true, this is false, you're not allowed to override that value. You're not allowed to override object 3's my value, okay? So let's see, is there an example? Oh, there we go. So here, we're going to do this real quick. So we're gonna print out, yeah, we're gonna run this and we're gonna see what we get here. So we should be able to get, here is my value, right, from object 3. So if I go here, here's my value. If I modify this, if I try to modify this, what's going to happen? I believe in non-strict mode, it's going to be a silent error. So let's do this first, just to make it more believable. So if I go, so this is old, right? So let me just type this real quick. So this is old, and then this is updated. So if we updated, we should be expecting this to be newly updated value. So if I do this, newly updated value, right? That's what we're expecting. So if I do this to be false, we're not in strict mode. It's going to be the same thing, right? So here is old, right? Let me just, here is old, and here is the new one, right? And if I'm in strict mode, I believe it'll throw me an error. I don't think it's going to fail silently. So let's see if this works. Oh, there we go. Cannot assign to a read-only property, right? So I'm not sure if you guys have used any of this before, but yeah. Anyway, so I'm just gonna go and talk about the rest of these. So the next one is enumerable. So enumerable is so you know when you use the in, so you're checking for the in keyword, so property in object. When you're using, oh right, oh I forgot. I already have it up here. When you use a for loop right here, you're essentially trying to get the properties out of the object, right? So what enumerable means is I am able to fetch the property from the object. Okay, so in this for loop, right, here we go. In this for loop, as you can see, object 3 dot my value, right? It's right here. It's enumerable, so I am able to find the property of those. So it's my value 2, and then it's going to be my value, right? So if I do this, I should probably delete the. Here is my. Where is this? Right. So as you can see, this is the object, right? This is the object. And then this is the, maybe I should make this more clear. And these are the properties. These are the properties of that object. I'm just going to run this again to make it more obvious. So if I make this into false, okay, I will not, so I will be able to view the, I will be able to still access the property, but I cannot use that in, I cannot enumerate over it. So I cannot use that, the for in loop to try to fetch the property of that object. Okay, so if I do this, right, so if I do this, as you can see, okay, I made a mistake right here. As you can see, the value of my value, right, which is this one, my value, it's not here anymore. But I could still, I know I deleted this, but I can still access this, but I just can't access it in this particular fashion. Okay, so that's what enumerable means. So configurable is, maybe it's obvious, maybe it's not obvious. Configurable is essentially when, why do I have this here? Configurable is when you want to redefine the properties again. So in this case, as you can see, I have configurable is equal to true. So what I could do, and I want to change the writable and the enumerable properties in the myValue property for object 3. So what I could do is I could go here and I can, you know, do this again. And then I'm going to change this to, I don't know, something else. And then I'm going to put true on everything. So if I do this, then it should work because it should work. We should have, I don't know if in strict mode, well, in strict mode, it's probably going to throw an error. But in non-strict mode, I'm not sure. So in strict mode, it's probably going to say something like, you cannot modify the properties descriptors of this particular object. So if I do this, I will get an error since I'm in strict mode. Hold on. Oh, so that was true, right? So I'm not getting an error. So once I make it to false, I should get an error, right? Because of this. Yeah. So it says cannot redefine property, blah, 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 right? It just means you cannot change the properties of that property, or you cannot change the property descriptors. So I think I just found this out today, but I believe if you do something like this, so if I do, let's actually find this out right now. I'm not sure if this will work or not work. So if I do a delete on that property, which means I'm just trying to get rid of it, right? The delete keyword here. So if I do this, let's do. If I do if I console log it out, I should be able to see just my value, right? With this value, the key is my value, and then I do this. Okay, I think I gotta make this true. Else it's not going to instantiate. So if I do this, and I do this, right, I see what I'm expecting. But if I do not configurable, then it will, and I try to delete the property, then I think it's gonna throw an error. And we're in strict mode right now. Yeah, we're in strict mode right now. Even if it doesn't throw an error, it shouldn't work after we console log it out. So here, I'm going to try it out. So we're expecting, well, let's just run it. Okay, so there we go. You cannot delete the property of my value, right? Because we're in strict mode, like I said. Yeah, and so that's another, what do you call it? That's another thing with configurable, the behavior of configurable. So if I'm just, so let's just prove to us one more time, and we're going to do it in non-strict mode. Okay, we're just going to take this out, and we're going to go, okay, we print out the object, we delete the value, and then we print out the object again. So because we're not in strict mode, it will just keep running. It won't throw any errors. Object 3, when we delete, because it's not configurable, we are going to see the same object. Okay, so if we do this, we're going to see the same object, right? So this is correct. Yeah, but if I do this, it shouldn't. I should see an empty object. There we go. All right. Okay. Cool. So yeah. So there's a bunch of different. Okay. So now that we know about property descriptors, we're just gonna go over. So there's some things. Let's see what I wrote some things here. Right. There we go. There's some functions called object.freeze, object.seal, and object.prevent extension. So we're not going to go through all those ones, but the one that I just want to demonstrate very quickly is object dot freeze. So this one, I'm just gonna take literally an example from NDN. So object.freeze essentially says that it doesn't allow, so it can no longer be changed. So freezing an object prevents new properties from being added, and no properties can be changed. So I believe every single property descriptor, enumerable, configurable, writable, pretty much it doesn't work anymore, right? So when you do something like that, so when you do object.freeze on a particular object, yeah. So let's see what happens here. So if it's in strict mode, this should throw an error. So let's do, yeah. So let's do something like this. Let's try to do, because I think configurable is not gonna work as well. I want to try to configure try to add another property descriptor to the to this object and see if anything goes wrong. So I'm just gonna take this example, right? And I'm going to add another property descriptor. I'm going to say random, and I am, yep, and I'm going to try doing this. So this stuff. So if we're in strict mode, we should see, we're in strict mode, yeah, we should see an error being thrown, hopefully. Object, random, okay. There we go. So as you can see, we froze the object, and then we try to redefine one of its properties, or we try to add a property, and and so it's not, we cannot do anything here, right? Because it's not configurable. So yeah, so there's some other ones, like I said, object.freeze, and yeah, Carmen, go ahead.
Just to clarify, so object.freeze basically just changes all of the property descriptors to false. Is that what it's doing?
Yes, and then I think the existing ones you cannot change as well, like new existing.
Oh, I understand. So it just pauses everything. So it just changes everything to false, even though you declared it as true before.
Yeah, and actually, I just want to tell everybody, I always get confused with like object.freeze and C. I don't know why. But yeah, like you guys can look up, because you guys can look up, what do you call it? Where did I write it? Yeah, you guys can play around with seal and freeze and prevent extensions yourself, just to kind of get the nuances. Like there are a lot of these nuances, and I'm always forgetting. Like like it's seal, it's like, okay, I think you can override existing ones, but then you can't add new properties, or you can't change new properties. There's all these little things that you might have to check it out yourself. But yeah, I'm just trying to show you guys that there's these things that exist. And I haven't, yeah, so I hope that answers your question.
Yeah, absolutely. I also had another question. I'm just trying to like piece together when would just like a real life case of when I would use this. Is this like you would kind of use this to define objects that you don't want to be able to like configure or update and change?
Yeah, like so that's a good question. So I'll give you I guess maybe I don't know. Okay, this isn't like the direct example, but I haven't read the source code for Redux or anything. Okay, but my guess is when they say like, okay, we want immutability when you hit the store, or like when you use a reducer, right? Like, okay, there's immutability because the object goes in and then the object comes out, right? Like I'm assuming in the source code or somewhere, if they wanted to reinforce immutability, they might just do an object.freeze or seal, okay, to really enforce that, okay, you cannot change an existing object, the properties on an object. You have to return the object, right? Is that a good example?
Yeah, makes sense.
And then maybe I guess like another even more practical one is for I guess like we have symbols now. So maybe in terms of enumerability, because I guess we didn't have symbols back then. So say you wanted to have a private property and you wanted to make the enumerability false, like just to kind of tell people, hey, this is not something you should be using, right? This is just a private property, right? I see that, because then it wouldn't show up in the object. Like you wouldn't be able to loop it and then try to access the property. That would be probably another good example, right? So like, let's say here, I'm just like, oh, I don't know, configuration. Oh, maybe, yeah, user. Let's say this is a user, right? And you have a private property called user ID. So you're like, okay, I want to make this not enumerable because I don't want anyone accessing the ID. So yeah, those are some, I guess in this case, it would just be like, for me in a real life, I would just like make this false, right? I would just be like, I got the users and there's a private property, or there's a property that's called ID, and I'm not using symbols, right? Because symbols are quite new, actually. It's only come out in ES6, ES 2015 or ES6. So in this case, I would see myself using something. So yeah, there's another example. Yeah, okay, cool. So that's that, and I know it's a lot to take in, and yeah, make sure you do some more research on property descriptors. There's a lot of these like little configurations that if you want to know more about, like what the difference between like prevent extension, seal, freeze, and all that stuff is about, you can look into that yourself. Yeah, so now let's move on to, I don't really have that much in the slides, but oh, okay, I think I'm okay. So here, okay, so not many words on the slide, but I want to move on to talking about this keyword in JavaScript. So essentially, it depends on which background you came from, but for me, I came from a more traditional background, and I learned, object-oriented programming with older languages like, C++, Java, and I guess C#. C#'s not that old, but kind of that like traditional way of thinking and the traditional object-oriented world. That this keyword is different from JavaScript, because the thing that I think a lot of people that come into the front end or into JavaScript, I think most people, like I've seen a lot of people, they'll kind of complain at how, I guess, that this keyword is inconsistent, or there's like no rules behind the this keyword, because in other languages like Java, off the top of my head, from what I remember, that this keyword is very obvious. You have a class and you create an object as an instance from that class, and that this keyword that's referencing like that this keyword is only going to be referencing that instance that was created from that class. Okay, so but in JavaScript, you can just start doing console log with this, or yeah, in the window, in the Chrome developer tools, and you'll find there's the window object, and then you're going to see like the kind of I don't know if people see it that often, but there's a precedence change in like knowing, because there are different ways that this keyword can be used. Not just it has to be in a class and that's all there is. You're gonna find a lot of confusion, right? And so especially when you do, I don't know if you guys have seen losing the this binding to closure. So through functions, like if you have a click event handler and then you have like a set timeout, the this binding, like the old school way of fixing that is like, okay, I lose the this reference, but the way to fix it is I just do like a var underscore self equals this. But yeah, anyway, I don't want to get into like those specific real world scenarios that I have experienced in the old days of JavaScript. But I just want to really talk about how there's actually rules to these things. There's different types of what we call like call site. So this keyword, because in JavaScript is more dynamic and you can use it in various different situations, most people don't know about those specific situations, and therefore they sort of are kind of stumped when it comes to knowing like where or which this keyword is referring to, right? So going back to the code, I have some things right here. So there's four what do you call it? Like bindings. Like there's four ways that a function is called. Okay, so and we call these how and basically when I say bindings, a function in JavaScript could be binded to an object, right? Whereas like if you're talking about some other language, that method or that function has to be from a class, and then like in JavaScript you could have one function, two objects, and you can bind that one function to those two objects separately. Whereas other languages, you don't really have that type of flexibility. So the first type of binding is the easiest binding. It's called the default binding or the global binding. It just means that when we do something like greeting, okay, when we do something like this, yeah, you just call the function, and this keyword is just going to be referring to, in this case, it's going to be referring to the default, which is like the window object on Chrome. So if you guys ever typed like console log this on Chrome DevTools, it's gonna be the window object on Node. I forgot what it was. I forgot what the object was, but it's gonna be some like process object, or it's gonna be something of that nature, right? Because we're in a different environment. But on Chrome, it's gonna be something else. And in this case, if I do this, it will be undefined because it's going to refer to like the global object, and there's nothing in the global object that has this property called message. So this thing should be undefined, right? So I guess we can do this real quick to demonstrate. To demonstrate that this is undefined, right? Okay, cool. So if I do, or hang on, let's just do 3. This will refer to this object, and we should be able to access it, right? The global object. So this is the easier one, the easiest one, sorry. So now something a little bit more complicated. We're gonna have what's called not more complicated. It's still simple. It's what's called an implicit binding. So this is when a function is going to be binded into an object, like an object literal here, where if I put this function here, the call site, the function that's being called is being called from the object. Right, and this is why it's called an implicit binding, because we'll see what an explicit binding is. Well, an explicit binding we use call or apply, right? But yeah, if we do this, we'll see the message sup, and then hang on, why did I comment that out? We'll see the message sup, right? And then yeah, that's what we're expecting. And then the explicit binding, which is basically very similar to this, it's going to be with the keyword call or apply. So in this case, I'm going to use call. So we take the function, right, and then instead of just doing this, okay, instead of doing this, we call, and then we pass in the object, right? So in this case, we're passing in object 1. So if I did this, right, this is passing in like the global object, which if I do this, then it's basically just running this, which is not what we want because we don't have access to message, right, in the global object. So in this case, we want to do object 1, okay? And now the call site has changed, which means that it's going to be, where's object 1? Object 1 is right here. It's going to be the same thing, right? So let's see if this works, right? It's going to be the same thing. So that's explicit binding. Okay. Now the fourth
So,
one. Yeah, go ahead.
sorry, Yu-Chen. So if you get rid of the greeting property that's in object one, will that greeting call still work? Where is it being called from, like the global function definition, or is it being called from inside the object, or does it need both when you use greeting.call?
Yeah, this is like this is not going to work because this is not defined then, right?
Sure, but what if you get rid of that property greeting in object one? Does that work?
Which line are we talking about?
On line 26, if you get rid of line 26 and then pop back in your greeting function.
Oh, I see.
Does this work?
Yeah, it should work. I mean, yeah, it should work. Yeah, I didn't see that actually. I shouldn't have had the. Actually, no, because well, yeah, no, this should work. This should work. Yeah, I should have deleted that. I should have deleted that earlier. Yeah, that was causing a confusion, but this should work. All right, there we go.
Okay, cool. Thank you.
Yeah, my bad, man. I shouldn't have.
Hey, mate, that's why we ask questions. All good.
Yeah. Okay, cool. So right. So now going to the other one, which is the last binding, or the last way, like the last call site. Which is basically the new keyword. So the new keyword, if you guys didn't know, there's actually like a lot of things that happen in the new keyword, and we're gonna come back to this when we talk about prototypes. But essentially, what happens is that when you use the new keyword, let me just look at the. Do I have an example right here? Let me see. I think I lost my example. So what you could do. Oh, maybe that's the reason why I had this thing here. I think I'm gonna need this. Just gonna go back. Yeah, so you know what? I'm not gonna demo it, but I feel I'm gonna make a mistake, but I'll just talk about it. So essentially, the new keyword actually invokes a function in some sort of way. So what happens is when so this is the steps that that happens when the new keyword is being used. Okay, so what happens is that object is, so a new object is being created, and then you can skip the second step, and then the this binding will set to that object, right? So this is essentially, well, I guess like if I already do this, I'll just do this real quick. So the way this happens is you would have like function person, and then be like, or hang on, let's do this. Do letter, and then message, right? So this is basically what I was trying to get at. So this is a new message. And essentially, when you use the new keyword, this thing, which is the most important thing, this binding is binded to that object that's being created with the constructor, with the function here. So when you do something like this, right? And I think we had the example in the very beginning. So letter one, you go to new letter, right? It goes through this whole sort of process, and then this binding gets the binding gets pretty much binded to the object itself. And so when you do something like, when you do something like what do you call it, letter one dot message, you're able to get the message, right? So this is essentially the fourth call, the four like binding site. So if I do this, we should be able to, let me comment all this stuff out. We don't need any of this. Yeah, so if I do this, then we are expecting this instance, right, letter one, to have access to this message, right, which is from this function. So that's pretty much it. So we're gonna look at some binding precedents. So I took this example literally from the YDK JS book. So essentially, what we're trying to do here is we're trying to put this into practice and see what goes what, like what goes first. So let's just go through this example. So we got the function foo, and then we're going to do a console log this.a. Okay, so that's it. And then we create two objects. So each of these have their own properties, right? And then foo gets put as a property into each of these objects. Okay, so when we're doing this, we're expecting, this is an implicit call, implicit binding. This is very obvious. It's going to be 2 and it's going to be 3, right? But what happens when we have something like this? And I know I wrote it in the comment because I was afraid I would forget. But if I do object.foo, okay, so object.foo, so I'm referring to this object1.foo, and then I do an explicit call. So instead of doing this, so instead of just doing this, right, I'm gonna do a call, and then I'm gonna attach object number 2 to it, right? This is kind of confusing, right? Do you guys see the kind of confusion? Which one goes first? Like, does this go first? Does this go first, or does this go first? Right? Do you guys see what's going on here? So what's going on is the precedence is like this. We have from bottom to top, it's the new keyword, and then explicit, implicit, and then default. So in this case, so this would go first, second, third, fourth. So this has a higher precedence than this. So when we do an implicit call here, right? This thing that's being called, that's not gonna work. This thing is going to work first, right? The explicit call. So in this case, let's run through the code, right? So foo.call, okay, foo.call, and then we pass in object2. So the object2 gets passed into so that this keyword will refer to this.a is going to be 3, and hence when we do this, it's going to be 3, right? And on the other hand, the second example, similar thing, right? We're trying to see what has precedence over what. This what do you call it? This object2, even though we call it implicitly, as soon as we do an explicit call, this has precedence over it. So that's why when this console logs out, this.a right here, right, is going to be a reference to object1, not object2. All right. So I hope everybody understood that, because this was kind of hard for me to understand as well when I was putting this together. It's kind of hard for me to explain. Okay, so let's see. So we also have another example. So this is a little even more confusing because you won't really see this that often. But what's going on is here I'm trying to basically show who has more precedence, the new keyword or the explicit binding. So in this case, let's just go through this example that I'm talking about. So we have, let's comment this out so I don't want to confuse myself. So here, foo takes in a parameter, similar like last time. This.a is equal to something, and then 2 objects, right? The first one having foo as the as one of the properties. Second object is empty. So what we're expecting, hey, object 1 dot foo, we're expecting 2, right? Object 1 dot foo dot call. So this is where it gets a little confusing. So remember the precedence, right? So in this case, it's going to be it's going to be the object2 that is being that is going to have precedence over the object1.foo, right? So in this case, object2 gets called, right? It's an empty object. We pass in the parameter right here. So foo gets called. This dot a is equal to 3, right? This dot a is equal to 3. So console.log object2.a is equal to 3. Okay. So the highest precedence so far is the explicit and then the implicit. Now the new keyword, so this is going to be even more confusing. We're instead of doing something like this, right? We're doing bar equals new foo, whatever. We're going to reference object1.foo. Okay, so in this case, what's going on is the object that this is referring to. So essentially, what's going on is this will become 2, and then this will become 4. So this is going to be the obvious one. So bar is equal to a. Just imagine running this without foo, right? And then you do bar.a, right? So the problem, the question is like, okay, if I did this, right, which is object1.foo, right? Does that mean that it's going to reference the object1? So like we're not even going to reference bar, we're going to reference object1 in terms of this keyword. Well, in this case, it's not because of what I just told you guys, the precedence. So when you do object.foo, right, when you're calling this and using that as a constructor with the new keyword, what's going to happen is it's going to reference, the object is going to reference this, right? It's going to reference bar. It's not going to reference object1. Okay. Yeah, so that's why this is going to be 2 and this will be 4, because this will always have higher precedence in every case. So here I just took some rules, going kind of reviewing this keyword again at the different call sites. So in terms of precedence, like I said, the new keyword followed by a function, right? That binding, so it creates an object, right? Remember what I said, the rules of the new keyword. The new keyword followed by a function, it will be, okay, first step, object's going to be created. Second step, there's a prototype linkage. Let's not worry about that for now. The third step is, okay, that this is going to refer to that, okay? And then the fourth step, the object is going to be returned. But the step number 1, step number 3, those are the most important ones. And then the second one, that call, apply, whatever, those ones have the second highest precedence, right? And then third one is just that implicit, the very regular call to a property from the object. And then this one, it doesn't really do anything. I mean, the default is the default. It's quite, there's no real precedent. It's just going to refer to the global object, or the window object, whichever environment you're in, right? So yeah, so that is this keyword. I know it's quite confusing. Hopefully you've seen some things that, I've shown you some things for you to think about so you can look more into it yourself. All right. So now we're going to get to probably the more difficult concept. And I'm not sure if everybody here, are experts at understanding the prototype system, or depends on, how about this? Everybody, maybe give me a number between 1 and 10. Like 10 being you're just an expert, you know everything about prototypes and how prototypes work in JavaScript. And then 1 being, okay, you don't really know anything. If everybody could, just put in the chat 1 to 10. 10 being you're godlike, 1 being you just don't know what you're doing. You have no idea. Okay, all right. Yeah, so yeah, the thing with JavaScript, as I explained previously, is that JavaScript is quite unique. It has this prototype system, and for me personally, I had a lot of I had a lot of trouble really understanding it because, well, number one, I guess I come from a more traditional background. Right? I went to school, I studied computer science, and I used languages before JavaScript. And when somebody say object-oriented programming, I'm thinking on one way. I'm thinking how somebody in the Java or C# world would think when it comes to objects. And so when I was learning JavaScript, I would hear about this prototype system, and I would read all these books, and I would like try to see these concepts like prototypal inheritance, and I would try to relate them to traditional OOP, right? How I would think how I would think it works in PHP or C++. Well, that's not how it works in JavaScript. And so for the longest time, I actually didn't know what the heck I was really doing. And so one of those aha moments was actually when I was reading YDK.js, and I saw this diagram, and I kind of didn't really know. So this diagram was pretty intimidating to me. I didn't really know what was going on. But when I was reading through the book, I kind of understood, okay, this is what's going on. And all these years, I've been thinking about kind of the wrong way, the way you think about object-oriented programming in JavaScript. It's not really object-oriented programming in the traditional sense. So right now, this looks like a pretty intimidating diagram, but I want to kind of go through a diagram or go through a piece of code, and I want to kind of trace through the code using diagrams, so that it could clear up some misconceptions, because this is something that's I feel like for most people is probably the most difficult thing, just because there's no really easy way to do it, except in my opinion through diagrams, right? So let's go and go here. So what I'm going to do is I am going to take this code right here. Take this code right here, and I'm going to just do like a drawing, and then we'll do some more complicated drawings as we move on to the inheritance part. So the first thing I want to make a note out of is I want to, hang on a second, I'll just move my window so it's a lot easier to see. Okay, I want to basically establish something beforehand. So as you guys remember, there's this thing called, so wait, hold on. I want to do this first. Hang on, let me just, so circles are going to be, So circles are going to be like functions. So when you do like function animal, right, in this case, it's going to be, it's just going to be function, non-invoked. And then squares are going to be objects. So what's going on is I want to just put a nice legend right here. I want to say this is just basically functions, right? Circles are functions, right? And then squares are objects. So we remember what each of those things are, because we're going to be drawing a lot of these. So before we even start, we have this big object, this big function. And you might have seen this object somewhere, object dot keys, object dot I don't know, object dot freeze, right? Object dot whatever it is that you can see on MDN. So that is going to have a property called dot prototype of, sorry, dot get prototype. So this one, okay, I don't know why not. So dot prototype, I can't spell prototype. Okay, so it has a property called dot prototype. Okay, well, it has access to it. And this is going to be an object. Okay, so we're going to establish that. And then in this object, let's just use our pencil, not pencil, the thing right here to type it. It has like, what was it, toString, right? What else does it have? Let me actually, I have some notes here that Oh, right. So it has stuff like, oh, I can't do that. It has like has own property, right? And then it has something like toString locale, something like that. To locale string, something like that, right? And that's what this object has, okay? It has access to those properties, right? So the object.prototype, which is this, has access to these properties that we all know and love and use. Not all the time, but that we all know and love. And so here, I'm going to just look at the lines of code and see what is actually going on. So the first thing that happens is before we actually run the program, this entire thing is set up like in the right corner. So now we can start actually, starting at line 12 to see what happens. In this short snippet of code. So what's going on here is we see function animal, and then there's a parameter, and then there's this dot name equals to name. Okay, so what's going on is that whole thing is going to give us a function, right? So this whole thing is just, ooh, oh crap! I just pressed oh crap! I pressed something. Okay, well, that is very fortunate. All right, give me a second, guys. Let me see if I can refresh this. Maybe I can do this real quick. Okay, nice. Yeah, I pressed something by an accident, and okay, cool. All right, now we're back to the same drawing. Okay. So now we have animal. I'm not going to press that button again. So we have this thing called animal. And essentially, animal has this property. Yeah, animal has this property called dot prototype, similar to what we have here, all right, with the object. And this object's name is going to be called animal.prototype, right? So this is the object. This object's name is called animal.prototype. So now, okay, that's essentially it. That the thing is declared, right? The animal function from line 12 to 14. That's all there is to it. So we'll come back to the name afterwards, right? And we'll see what happens. So this whole thing, it works. And line 16, that's where the confusing part comes in. So line 16, we do an animal.prototype.speak equals that function. So what happens is here in this, what I just said, this object is called animal.prototype. So we're going to basically add a function, right, in line 16, and we're going to put that function, we're going to put that function right here. We're going to put that function right here. And it's an object. And that's it. So I'm not going to write the whole thing out, but this is going to be a function. And then line 20, okay, this is where it becomes more interesting now, because now we're going to have a dog that is going to call the animal function with the new keyword. So essentially, we're instantiating a new object out of the blue. So it's going to be called dog. So here, it's going to be dog. And if you guys recall, to what I wrote here, or what was stated here, which is a brand new object is created, right? So these squares, these are objects. And then there's going to be this prototype link that's going to be actually connected to the dot prototype object. So in this case, there's going to be a linkage, okay, from here, okay, from here to here, and it's called so this linkage is an internal linkage used by JavaScript, and it's called prototype. So it's called with the 2 brackets prototype. Okay, and we're gonna look at this a little bit more afterwards, but when I get more into detail. So this is what happens, but then you also recall that the other step with the new keyword, is that we're gonna set the binding to that function, and we're also gonna have to put the correct properties, such as this one, into the function. So here, this is a property. This is not a function. So we're gonna come here and we're gonna put name into the dog object, right, when it's instantiated. And so cat, it's the exact same thing. Okay, it's going to be, let me just do this real quick. All right, it's going to be linked, and then there's going to be this prototype internal property that is going to be also, I'll just write proto. It's called prototype, but I'll just write proto because I want to keep it consistent. And so if you guys notice already, well, this happens. Wait, what happens here? So I actually forgot to do something, which is this actually gets connected to this object as well. And it's called, like I said, proto. Okay. So yeah, and so what was the next one? Cat.speak. So going back to cat, let's see, cat has a function called speak, all right? So it's going to be placed within, not the prototype, right? Because this is animal.prototype.speak. We have cat.speak. So cat actually has, sorry, not cat, what do you call it? Speak. So speak is actually a method here as well. So we've drawn the diagram, and the question is, okay, what is the output going to be? So before we actually run the code or anything, we'll look at the diagram and then predict what the code is gonna do. So what's going on is when I do dog.speak, okay, the first thing that happens is the object, which is dog, is going to look here. It's gonna try to find the method speak, right? So speak, it can't find it. So what's gonna happen is it's gonna go up to, there's an internal property in JavaScript called, you guys have probably seen it, which is the _proto, right? When you click on it, there's a bunch of these crazy things that come out. And this essentially will pretty much go up the chain, right? This is basically this JavaScript internal property, okay, in the specs. This is the actual property that we can access, this proto, okay? We're just gonna call this proto from now on. And essentially, it's gonna go all the way up, and it's gonna check, okay, do we have the method speak? Yes, we do. And that method is, that function is in the prototype. So we're gonna call this particular, this particular speak function. So now cat, what happens to cat? Well, I just said, we are going to look for the function speak, and we already found it. So therefore, it's going to be on that instance, right, on the cat itself, not on the prototype, the animal.prototype, right? It doesn't have to go up that chain. So from that, tracing that we just did, well, now we can tell then the first one is going to be, well, it's going to be this dog.speak is going to be just a generic speak function, which is, hi, I am, oh, right, I forgot about this. So now, right, I am what? So this, this keyword, remember how in the beginning when we were trying to construct those objects with the new keyword, it was binded to that object itself, and we actually set a name up, right? So in this case, I actually forgot to do this, but I should have here. I should have put name is equal to dog, right? Name is equal to dog. So this is going to be dog. Yes, Dan?
Sorry, Yichen, I might have missed this, but can I ask why that central speak, which is a function, is in a square rather than a circle? Or is it an object?
Yeah, it's an object. So as you see object, that object.prototype, that's an object. Right? So the animal, which is a function, dot prototype, it's going to be an object.
Oh, okay, because it's okay, so because it's not a speak method, it's a prototype method, right?
Yeah, exactly. Yeah.
Okay.
So yeah, anyway, going back to kind of just tracing the code, this, right? Now I put the property here, and it's the same thing with the cat. The name is going to be, I'm just gonna write this so we don't forget. It's going to be cat, right? And essentially, this is going to look for a property here first. If it cannot find it, then it'll look here, right? But in this case, we already found it. So, hi, I am a dog, right? And then the cat, right? We find the method speak, right? Speak is right here. And then in speak, we're trying to reference this dot name. Well, we can already find it in this object, so there's no need to go up, right? There's no need to go up. So meow, I am a cat. So I'm gonna run this, and hopefully this whole thing runs properly as as anticipated. So let's go demo 3. There we go, right? So we talked about how this sort of implicit going up the chain and then looking for stuff, right? What happens if I do this? So if we look here and we remember how if you look here, let me just maybe bring this up so it'll be easier. So notice how we have all these, things on MDN, right? And you see, oh, hey, there's all these nice, methods like object.phrase and whatever. Well, anything that has an object.prototype prototype, those are the things that we can access from any object, right? So in this case, we can actually access this. We can actually use, for example, something like this, right? Or maybe this one, or whatever, toString, right? We can actually access it because how it works in the chain, we just look at how it goes up the chain. Here, if we do something like cat.hasOwnProperty name, so clearly, cat doesn't have any other. It has one attribute, which is the name, and then it has one method, which is speak on itself. So when we do something like this, it's gonna look, right? Cat.hasOwnProperty. Well, it can't find it in the instance itself, right? In itself, it cannot find it. So it's gonna go up to animal.prototype, right? And we see there's nothing here. So then it's gonna go through this, chain. It's gonna go to this object, right? Remember how we said previously, oh, there's this, what do you call it? There's this master object, which is called object.prototype, and it has all these nice features, right? Well, toString has own property to locale string, we can access it. So if I do something like this, I should be able to get a true, right? We shouldn't have some error. So we should be able to access true. We should be able to get true because the name of our cat is called cat, right? So if I do this, it's gonna be true. right? And so this is kind of how this whole thing works, okay? And this, again, I don't know if all of you guys knew how this worked, but this is, after looking at this is kind of when I realized, oh, okay, this is how it works. And all these things in the documentation, right, are not just magical, right? So for example, you can't use, cat.isFrozen because it's not on the prototype chain, right? It's a direct function into, it's a direct helper function into the object function. It's not on the object object.prototype object, which you have access to through this internal linkage. So I hope that clears a lot of things up, because now we're going to go, well, okay, I guess I have another example here. So I just, for example, here, I added another random function here just to kind of prove my point. Okay, I want to add something to the object.prototype.print stuff. So here, it'll just be like, we have another function, and just to prove to us that it does work, we're gonna create a new function, right, called print stuff to screen, okay, and we're gonna call it, and we're gonna see if it actually works. And yeah, there we go, it works, right? Random text. We're not returning anything. That's why we're seeing undefined. So yeah, and then something that I guess it's not that I forgot, but I wanted to leave for later, which is there's actually another kind of semi-hidden property that actually gets created the other way. So what happens is there is a constructor. So you know how sometimes you'll get a little type hint, right, on whether an object of what type it is, like is it created from an animal or such. So for example, if I do console, not sure if this will give me in the on the screen, but let's see if it works. Yeah, there we go. So you see how it will kind of print the constructor, or print like how it was constructed by what function, right? So there's actually another hidden property, not hidden, but there's another property that people don't really know of, which is the dot constructor property. So this automatically gets created when this whole process happens. So let's see. So what happens is there is a dot constructor property on the what do you call it? On the animal dot prototype object. Okay, and so what happens is it's not on the instance itself. So for example, the dog, like here, the cat, when it's looking, so what happens is when we're calling the dog.constructor, okay, we're looking at the object first and we can't find it. And then we look here in the animal.prototype and we can find it because that's what it is. We could do, there's a property called .constructor. So that's why when I do this, I'm going to get animal, right? So if we do this, we should be able, if we run the code, we should be able to get a true, right? It should be the exact same type. So I'm gonna run this. Okay, this always happens. Demo 3. So if I run this, it's true, right? And then something else to note, this is going to be important later on when we go a little bit deeper into the inheritance part. But the other thing I want to talk about was this, internal linkage thing, right? This prototype thing that this functionality that lets us traverse through this entire all these objects, right? So there, if you recall, if you actually see, recalling when you go into the Chrome DevTools and then you click on some arrows on the objects, right? You'll see a hidden property. I don't know if Chrome shows it anymore, but I'm sure Chrome still shows it. Firefox, maybe not. But essentially, what happens is you'll see this dot __proto __. And essentially, this is just a way. This is basically supposed to be a hidden method, but you can actually access it. And so this is essentially that chain that we're talking about, except we can actually access this method. And so if you look here, for example, dog, if I want to access the dot prototype, so the animal dot prototype, right, and I want to see what methods are in there, I can actually do a dog dot underscore underscore proto underscore underscore, right? Or I can do animal dot prototype. So what you'll see then is you'll see a bunch of methods that are added in the animal dot prototype. So in this case, it would just be speak, right? Because that's going to be the only method that we see. So if we do this, I'm just going to take this out, and then I'm going to show you guys that these guys, well, let's do this first. So, right, there's the animal, right? Animal, what do you call it? The method that we added, right, in the animal.prototype. And then if we do animal.prototype, it's going to be the same thing, right? And so these are indeed equivalent and the exact same object. Yeah, so that's what we should be expecting, true. Yeah, so now I'm gonna move on to kind of one of the hardest topics that, you know, most people get really, really confused because, you know, they don't really take the time to understand this stuff first. So I'm gonna go, and I took the liberty of taking some code, here, and just, you know, pretty similar to what we have previously, but I took the liberty of taking some code, and I added some inheritance to it. So I'm using traditional, you know, ES5, right? I'm not using ES6 classes. I'm just using ES5 to demonstrate so that we can have a better understanding of how actually the prototypes work in JavaScript. So what I did was I added, so I'll just go through this code because I think it is different. So I have dog, and then I add this function identify to the dog, and then I have cat, and then I'm calling dog.call. So I'm just basically trying to call the constructor. So this is like similar to super, right? And if you're using classes, I'm just trying to call and invoke the constructor from dog, right? I mean, we don't really need to use this either, to be honest. Actually, yeah, I think we do, but yeah, this is essentially the super keyword. And so the crazy part is, you know, how do we link all this stuff together so that we can do something like, you know, cat1 or cat2.speak, right? So we have speak right here, but then when we do speak, we're calling the identify, right? So remember, dog is the parent, right? And if we have a cat, we're not able to reference this, obviously, right? So what we're going to do is we're just going to go through the diagram pretty quickly now, since everybody knows how this thing works. And we're going to see how, quote unquote, you know, prototypical inheritance actually is. It's just basically a bunch of objects linked to other objects, and you traverse up this internal chain to be able to like share like methods and properties with each other. So let's just go and do this real quick. So, okay, remember circles are functions, right? So circles are functions. So we're gonna have dog. Oh wait, oh man, we're gonna have dog. Oh wait, I'm putting a square. I don't know why. So dog, right? And then immediately after dog is what do you call it? Is instantiated. There's this other thing called dot prototype, right? So dog dot prototype. That's the object that is created. So we're gonna have this object, and I'm gonna write this. I'm gonna draw this a little bit bigger. So draw this a little bit bigger. Just close some windows real quick. Yeah. So now we have, okay, this is great. We have identify. So dog.prototype.identify. Let's add that in. So that's a method, right? I hope I can write this in. Identify. That's a function. And then we have, so that's done. We have cat. So cat is going to be a circle as well. And there's a property called .prototype of. And that this is also going to be an object. So, okay, this looks good. But here, line 62, this looks like it's some really confusing thing. So what's going on is this is the quote unquote inheritance part. So what we're trying to do essentially, okay, is if you think about it, let's say we create an object right now, right? Like visually speaking, and we call this cat1. So there's going to be an internal chain, right, that goes to here, right? It's going to be this. We somehow need to go from here to here. So if we call identify, how can we make it so that identify, so what's going to happen is we're going to come here. There's no function called identify in cat1, clearly, right? There's no function in the cat.prototype, right? So how do we make it so that we can go from here to here? Well, that is essentially what we are doing with that one line of code right there, which is the so cat.prototype, which is this thing, okay? What this line is doing is it's saying, okay, I am going to replace this, right? That was already created, right? So it was already empty pretty much. So there was nothing in it. I'm going to replace cat.prototype with object.create, which creates an empty object. Okay, it creates an empty object. And then it will point this object that's being created, it will point the .prototype, okay, to that object that was specified. Okay, so in this case, if I wrote this, right, this object would, this would be an empty object, and this object .prototype would point to this empty object that's right here. Okay, so if that's confusing, that's okay, because I'm gonna literally use this example. So what's going on here is person, right? Person. So you got one object, and then we're creating a new object. So object.create, so creates an empty object, right? And then this person, okay? So you see how update an existing object as the prototype of the newly created object. So it's basically saying that we can go up the chain now and we can access these things. So this one, yeah. So here, if I do, if you look at the code, the only reason why me, right, which is an object that I created, which is empty, is able to access this method, right, and we'll make it work, is because this is now this empty object that we just created is now the .prototype of is linked to this object. Okay, so this is essentially what's going on, and this is essentially what makes this thing right here possible, because we're saying cat.prototype is going to be a new empty object, and that empty object is going to be linked to the dog.prototype. Okay, so now if we do this, this is pretty much what we're aiming for. We've accomplished it. This one thing has accomplished this thing that I just circled. And so if we do, so now let's just kind of run it down the code, and we say cat.prototype, right? There's speak. So let's just do this real quick. Let's write speak. Maybe I just use blue. So speak, right? It's the method. Okay, great. Now, when we create, when we call cat1.speak, we're just gonna comment this now. When we call cat1.speak, it's going to, it's going to be able to go up the chain, and then it's going to be able to access identify, right? So in this case, I know I wrote in the comments out there, we can run it, and let's see if this works. So speak, right? Speak. Cat has nothing, right? There's nothing in cat. There's no speak. We go up the chain. Okay, speak. Speak says, okay, hello, and then I say, I call this dot identify. Identify, there's nothing. There's nothing, no identify here. There's no identify there. But there's an identify that we just linked to the other object, which is the dog.prototype. Okay, so now, I'm not going to draw cat number 2, but cat number 1, it's going to be able to print out, hello, I am cat 1. Okay. So I'm just going to, hopefully I don't have anything else. Just uncomment this thing out. Comment this thing out. Yep, and we're going to run it. And so here, there we go. So if we didn't do this, well, let's see. I mean, it shouldn't work. I don't know what's going to happen. It's going to just throw an error, right? Yeah, it's going to throw an error. It's going to say, what's going on here, right? So this is proof that we made it work. Now, there's a small problem here, okay, which is, it's kind of unfortunate, but if we do this and we get the constructor, so I wrote here, what do you think is the constructor here? Anybody want to take a guess? Is it going to be cat? Is it going to be...
Is it going to be animal? Oh, wait, is there an animal constructor on this?
Yeah, so hang on. Yeah, I'll just... So dog, and there's cat. There's only 2. So it's a 50-50. It's a 50-50 right here. Okay. Okay, dog. Okay, we're getting dog. Any cats here? Any cats? No, nothing? Okay. So...
Yeah, I think cat. I'll go with cat.
You go with cat? Who's talking? Dan? Was it Dan who's talking?
Yep.
Okay. So we got Ryan that says dog, and then Dan saying that it's cat. All right. Okay, let's see. One of you guys is gonna be surprised. Hold up. So this is cat 1. So the first one is cat. Sorry, the first one is cat 1. Second one is cat 2, and dog. It's not cat. So why is that? Right? Like, what's going on here? I mean, this is so confusing, right? What's going on here? So what's going on here? Yeah. So let me just go back to the drawing. So what's going on is, if you recall, I said that basically I left out the step again, okay? Which is when dog is created, right? There is a dot constructor property, okay? But the problem here is when we did an object.create, okay, we did an object.create, we didn't use the new keyword, right? And if you recall, so if you don't use a new keyword, like, there is no constructor, right? Because it's a blank object. It's like an object literal, right? So that's the reason. And so here, this wasn't doing this, right? So that's why, like, this, there's none of this. So when we do cat1, right, we're like, okay, we're going to go up the chain, cat1.constructor. So there's no constructor in the object instance itself. We're going to go up. Well, this thing doesn't exist. So then guess what? We're going to go through this chain right here. And then we're going to go through dot constructor, which means we're going to get dog. And hence why we have dog instead of cat. Are you disappointed, Dan? Okay.
Worse things have happened.
Yeah. So that's the reason, right? And essentially, I think that's, and essentially that's the whole, essentially that's one of the biggest problems why, I don't know if you guys have used like libraries and they'll try to mimic like this type of stuff pre-ES6. It was really hard to like have true quote unquote inheritance in JavaScript because you would get stuff like this and it would be very confusing because like imagine I'm debugging this and I'm like, wait, I created a cat, how come it's a dog? Well, the explanation is right here, okay? So how people would mitigate, well, how people would kind of create libraries around this would be like, okay, you know, let's get around this by doing this, right? And as you can see, I wrote a comment here. So we're like, okay, now you know it's going to be good, but the problem is, so if I did this, right, it's going to be good, right? There's going to be no. So as you can see, cat.prototype, right? So cat.prototype is here. Sorry, cat is here. Cat.prototype is here, and then we're going to go back. We're going to go back here, and then we're going to declare a dot constructor. Like that's essentially what I'm doing. But you actually don't. Oh gosh, what did I do? You actually don't want to be doing this because of my comment that I just wrote here, which is the enumerability, right? Which is if you do this, then you're going to actually, because you don't want a problem like this property doesn't show up. It's not supposed to show up. And if you do it, it's going to show up. And if you start using it in like a for loop or I don't know, like something like that, it's not going to work out. So you would actually have to do this really ridiculous thing, right? And we went through probably descriptors before. And you would have to do like enumerability false. And so you would need all this code just to like make this one thing more manageable or more intuitive, right? So when you're debugging, you're not like, oh, this is a dog instead of a cat, right? So that's a little quirk. So now let's put this to the test. All right, so let's I actually forgot what I was gonna do exactly, but I wanted to do something with arrays. So let's say we want to do something like, now that we know this whole chain, okay, why don't we do something with arrays? Like, why don't we do something where I'm thinking of, print all elements. Like we want something, hold on, it's gonna let me. An element access should take an argument. Okay. Oh, okay. It wasn't anything. Okay, it was just highlighting. Yeah, I guess whatever. It doesn't matter. So what I'm thinking is if we were to do something like this, right? And since we might be out of time, I'll just do it very quickly. If we were to do something like this, right? And we want to print out, 1, 2, 3, right? We just, or maybe we want to print out the middle element, right? Let's do this. Print middle element, right? Or maybe I don't know. Okay, I'm making this up, but like print the odd element, right? So if we were to do this, we would simply just see 1 and then 2, right? So in this case, since now you guys know what all this, linking, prototype linking, and all this stuff is, you guys probably have a better idea now, because what this is essentially arrays, strings, right? They're basically, you have, okay, so when you create an array, right, this would be more evident. You're essentially doing something like this, right? This is the bottom is the literal form, but the actual form is, this, right? It's new array, and then you can have 1, 2, and 3. And so where do you think this stuff is coming from? Well, it's coming from somewhere. There is this thing called like an array function, and then the array.prototype, which is this, which is this object, right? And so of what I just said now, we can clearly see that if we want something like this, we can append something into the array global array function, right? Or array.prototype in this case. And so in this case, now this probably makes a lot more sense because if we do this, so let's say do this, and then we do this, and let's comment out these. Right, let's comment out these. So if I run this, it should give me like, I don't know, property not found or something, right? Yeah, it should give me an error. So it'll be like, it's not a function, okay? So, hey, let's create a function and let's make it so that every single array can use this, right? Print odd elements. So now we'll just do this, and we're not going to take any arguments. And so for those of you who are like, how do I access the elements? I believe you can do it through just this. So I think this will give me literally an array of elements. So if I do this, yeah, there we go. So now we have access to the properties, or which is the array. We can do our little for loop right here, and let's do length, and then I++, and we'll do console log if odd. We'll do I so what I mod 2 is equal to 1, then we will print that element out. So this one, this. So I'm doing this live. I don't know if I did it correctly. Hopefully it works.
Yeah, I think it has to be the other way around.
What's the other way around?
I modulo 2 is not equal to 1.
I want all odd elements, right? If it's 0, it's even. If it's 1, it's odd.
Oh yeah, sorry, my bad. Yeah.
Sorry, I should have said odd indices. My bad. Right, I think maybe that's why you were confused, perhaps.
No, I was just confused in a completely different way. It's all good.
Yeah, I think you were you got the mixed up, right? The odd and the even. Anyway, so if I do this, I'm expecting 2. Okay, hang on. Yeah, I'm expecting. Let's make this easier on ourselves, because yeah. So I'm expecting 1 and 3, right here, 1 and 3. So hopefully that works, and it doesn't work. Print odd indices. Print odd elements. All right. And there we go, right? And this is only achievable because we took this global object and then we just referenced the dot prototype, right? And then, yeah, and we had this custom-made function. So this here, it was it's basically one of those little square boxes here, right? Imagine it's a square box. There's a prototipable chain that is linked to array.prototype, and that's how we were able to access this particular method. Okay, so we have like 7 minutes left, and I'm just gonna kind of go back and talk about just gonna have some water. Talk about traditional OOP versus what we just saw right now. So here, going back to kind of traditional OOP, I just took this slide from last year's from Fabio. So OOP is a programming paradigm based on concept of objects, which contains data in the form of fields, attributes, whatever, and they contain attributes, properties, and methods, right, which are functions. And essentially, one of the things about there's actually 4 pillars of object-oriented programming. I can't remember. Actually, I think it's polymorphism, encapsulation, and abstraction, and inheritance. And so one of the kind of confusing things for people that come from different backgrounds, especially traditional OOP backgrounds like me, is we think of inheritance as being this. So what's going on is on the left side, you'll see non-prototypical inheritance. And then on the other side, you'll see kind of the JavaScript inheritance model. And this is very confusing because if you learn traditional OOP, you would just be like, well, this is how it works. This is one of the pillars. And but then you hear people, they're like, oh, JavaScript is object-oriented, but then in reality it's not. But then it kind of is. But then it's not really under the hood. But then you also have things like ES6 classes that kind of make it look like it is object-oriented. But then it's really just underneath the hood. It's just doing all the prototype linkages, right? So when I was learning it, and most people go through this phase where they just assume that inheritance works like this, where I have a class called dog, okay, and I inherit, right? I extend another class called animal. So animal, let's say I have, I don't know, like certain properties, right? Height, weight, I don't know, eye color. And then dog, let's say you would have like a particular, attributes, right? Or particular methods, right? Like maybe, bark, right? That's one method you can use very particular to a dog. Maybe, I don't know, is colorblind. I think dogs are colorblind, right? So there's that property. And then, cuddliness, right? From Dan. And so what happens is these arrows that are pointing, okay, they depict what happens when you have like a blueprint, right? You got a blueprint, and then you want to mass produce objects. So these objects are instances of these blueprints. So these blueprints and these objects have very little to do with each other. These instances just take the blueprint. So these are the properties of the dog. Okay, it has, this many legs, or this fat, like this is the top speed. This is the species, and then inherit certain other properties from the parent, which is animal, right? Animal, you'll have more genetic things like height, weight, whatever, right? And it's like you take these things and you just kind of put it into dog, and then you create an instance from that kind of new blueprint, right? It's the dog plus the animal combined blueprint. But that's completely different from the JavaScript way or the prototypal way of doing things, because what's going on here is when you create, an object, right? You notice the arrow's going the other way. So what's going on is a function or a class, right? I'll just say function. A function called dog, it immediately has this dot prototype property that is already built in. So what's going on is when you create objects, right? These objects are linked to that object. So the D1, right? Dog1, dog2, dog3, they're linked to the objects, right? There's an actual linkage that's happening. Whereas on the other side, it's not really like that. It's more about mass production, and there's no real linkages, right? And so that's the confusing part, is when you create an object, it's always going to be linked to something, to a dot prototype, right? In this case, it's going to be dog dot prototype. And so in this case, the inheritance part, as you can see the arrow, it's going the other way around, because we're looking at D1 if there's a method called bark, or not bark. Let's say we want to get the height, get height, right? That's the parent method in animal, or animal.prototype. We can call animal.prototype. We could call get height, and we're going to say, oh, dog animal.prototype doesn't have it. So we go up. We go up to animal.prototype. Does it have it? Because we inherit it from it, right? And so that's the way of thinking, which is, one is it's like a factory. We mass produce things right on the spot. And the other one, which is JavaScript, is it's produced, but it's all linked because we still need that linkage, right? So that's the difference between JavaScript and other traditional OOP languages, right? And we got 1 more minute, so just I'm sure you guys all know this, but whatever I just talked about, animal, right? Cat. This is very simple. So what I'm doing here is, I'm using extends, right? I'm calling the constructor. Literally what I did here with all this stuff, except I'm doing it with ES6 syntax. But in reality, all this stuff, right, under the hood, you're gonna, if you just dig a little bit deeper, cat. Look, it's if you can access animal.prototype like this, right? You can add another method, get get name, right? You go to function, right? This is, if you do like this is just the same thing as this, right? So under the hood, it's just, that's how it's what's going on under the hood is that it's just that picture that I showed you, and it's just objects linking to other objects and then going up the chain, right? It's not that traditional sense, even though, again, like I said, this is just syntactic sugar, right? Yeah, so that'll be it. We're 1 minute over, and yeah, that was I don't know if that was a tough one for everybody. I don't know if everybody is overwhelmed right now with a bunch of details, but yeah, any questions for anyone? Yep.
Carmen? Yeah, no, that was really good. It was really good, like, overview and intro. It's definitely something to look more deeply in for me, for sure. But I was wondering if you can also share like your little demos. I think that'd be nice to kind of reflect on once I read more about it.
Oh yeah, so yeah, like what I'll do is yeah, I'll create a GitHub I'll create a GitHub repo and I'll post it, and then like I'll commit it, and then I will put a link like on all the slides that I have created, like at the end. Like I'll update some of the older slides as well, but I'll update this slide as well after, and then yeah, and so you guys can reference the GitHub repo.
Yeah, that would be rad. I think, yeah, I'm one of those learners where I just need to play with it myself and like create it as well, and then I'll, get more into it.
Yeah, hopefully, I don't know, I didn't go into super detail because I just wanted to make sure that, what do you call it? I just want to make sure that, I don't know if you could tell, I just really want to make sure, people just kind of know the basic building blocks, because everything else is just whatever, like there's a bunch of these like extra functions and these nitty gritties, but I don't think those are that important. Just understanding the big picture of, hey, this is how all these things work, and being able to debug it yourself. Yeah, that's the most important thing. Anyway, any other questions? Okay, all right. Yeah, a lot of thank yous. You're welcome, everyone. So if there are no other questions, I guess, yeah, I think that'll be it for me. I guess you could stop the recording now, Michelle.